Hi, I'm Mike Stanzik and this is Digital Electronics Classroom. In this video we're going to be talking about Ohm's Law and one of the foundational laws along with Kirchhoff's laws that allow us to analyze linear circuits. So let's get started. Ohm's Law. Oops. I'll just combine it. Ohm's Law. Okay, great. So I just want to start out with a graph. So this is called an IV curve, or an IV characteristic. And the idea is that if you take a resistor and you put a voltage difference across it, then you're going to generate a current. And this is V1, I1, and R1 here. And so the voltage is kind of the cause of the current, right? And then the current is the effect. And then the R here is sort of the qualifier. It's the thing that moderates of the effect. And so VI and R. So let me just kind of show you. So on this graph here, if you increase the voltage, and what you would see is that the current would increase from 0, and it would look something like this, a linear positive sloped line, okay? And so then if you take a different resistor and you did the same thing, you might get something that looks like this. And the question is, well, how do we analyze that? What's the difference between those two resistors? And we do that by looking at, if I choose a particular voltage and I apply it to both of those resistors, what do we see in terms of the current that goes through them? And so I can see that for one here, so let's call this say RA and RB. Ooh, RBs. And we can see that for RA, we would generate an IA, and for RB, we generate an IB for the same V, okay? And so which one of those currents is bigger? We can see that IB is bigger than IA, so it allows more flow for the same push, for the same voltage that's applied, okay? And so we can say that that thing resists the flow less, or it conducts the flow more. And so we have a slope value here that is directly related to how the current flows based on a voltage applied to that element. And if we look at the slope actually is not a resistance value, it's what we call conductance value. It tells us how easy things flow. And as you can see, as the slope increases here, the resistance decreases. And so we have one of the relationships that describe that kind of thing is that if something increases, the other decreases, is an indirect relationship. So what we find here is that the slope is equal to 1 over the resistance. So if I wrote an expression here that started with y equals mx plus b for one of those lines, and then on the y-axis I see I have current, and on the and we just said the slope is 1 over r, and then on the x-axis I have voltage, and then the y-intercept here is at 0, so we can drop that out. We get this relationship right here, and this relationship is Ohm's law. So typically we write that in the form that either looks like this, I is equal to V over R, or a lot of times you see it written as V equals I times R. Okay, that's the Ohm's law equation. I like the first one better because, actually, that kind of looks a little confusing. Let me just start that. Okay, I like this first one better because it sort of goes along with this effect cause moderator framework. The effect is the current flowing, the cause is the voltage applied, and then the moderator here is that resistance. Okay, and so just a quick review. Remember that current is measured in amperes. And voltage is measured in volts, and then resistance is measured in ohms. And they also have their short symbols A, V, and omega. Okay. So that's Ohm's law. So let's do a quick example. All right, so say I had a resistor, and I have this voltage across it. We'll just use V1 again and R1. And let's make R1 equal to just 100 ohms. Okay, and I want to know what I1 is. Okay, so if V1 is, say, let's say it's 5 volts, well, how would we figure out what I1 is? First off, one thing I didn't talk about is the polarity of the voltage. You see this plus and minus right here on the voltage, plus and minus. That means that the positive side is higher voltage than the negative side. And if you have a higher voltage, that's going to push towards the lower voltage, and that's why our positive current is pointing to the right. And so we should always label our polarities and our directions for our voltage and our currents respectively. All right, so this is simply a plug and chug. And so we have I1 is going to be V1 over R1. And so it's going to be 5 volts over 100 ohms. And so that gives me 0.05 or 500 amps. Now typically we wouldn't leave it in this form, and so I would switch it into milliamps. So that would be 50 milliamps equal to I1. Okay, and that's all we have. That's all there is to it. So that's your introduction to Ohm's Law. I hope that was valuable for you. I'm Mike Stanczyk with Digital Electronics Classroom, and as always, I'm wishing you a wonderful day.